Hey guys, welcome back to the era of tech. Today we are diving into one of the smartest natural phenomena in electrical engineering, the piezoelectric effect. This is the amazing ability of certain crystals to produce electricity when pressure is applied. From microphones, sensors, cigarette lighters, ultrasonic machines, and even energy harvesting flows. The piezoelectric effect is everywhere. So let's break it down in the simplest way possible. First, what is a piezoelectricity? Piezoelectricity comes from two words, piezo and electric. Piezo means pressure, electricity. So it simply means electricity from pressure. Certain materials have atoms arranged in such a way that when pressure or vibration is applied, the positive and the negative charges become separated and generating a voltage. Examples of piezoelectric materials like quartz, rochelsat, lead zirconate, titanate, tourmaline, PVDF, or a piezoelectric polymer. So are the examples of piezoelectric materials. How it works. Let's start with the direct piezoelectric effect. For the direct piezoelectric effect, when mechanical stress is applied, like pressing, bending, and tapping, an electric charge is produced. Let's jump to the inverse piezoelectric effect. When we apply electricity, the material vibrates or changes the shape. This is why piezoelectric materials are used in ultrasonic transducers, buzzers, and actuators. Generating electricity using piezoelectricity is simple in principle.
One footstep will give you about 20 seconds of light on an LED fitment. But what it does as well,
like pressing, vibration, or even wind, this produce a small voltage. Example: special tiles installed in dense floors or pavements can generate electricity every time someone walks or dances on them, potentially powering street lights or sensors. A simple piezo tile under a footstep can generate about 5 to 10